So now we would like to talk about properties of determinants. Number 1, if you interchange two rows of a matrix A to obtain a matrix B, then the determinant of the new matrix is equal to -1 times the determinant of the old matrix. Okay? So if you interchange two rows, then make sure you put minus in front of the determinant. If you multiply one row of A by a scalar K, basically by a number, to obtain the matrix B, then the determinant of the new matrix is that number times A, times the determinant of A. Okay? So if you multiply or divide and make a row by a number, then you need to put the number in front of the determinant. But if you add a scalar multiple of one row to another, to obtain matrix B, then the determinants are the same. So scalar multiple does not change the determinant. If you interchange rows, you have minus put in front. If you multiply by a number or divide, put the number in front. But if you add scalar multiple of one row to another row, then the determinants are the same. So those properties will help us in solving determinants. As we saw in previous lecture, that it is very beneficial to keep expanding if you have zeros by the row of zeros. So we will use those properties to make those zeros first in a row or in a column basically. And then we can expand by that column, then the calculation will be very easy. So now let's see examples how that works. For example, if you have A, my matrix A is equal to 1, -1, 2, and -3. I would like to show first that those properties are true. So matrix B, we change those rows. So I have 2, -3, and 1 and -1. Find determinant of A, find determinant of B, and see if indeed it differences by -1. So determinant of A is 1, -1, 2, and -3. Cross multiply, so it's 1 times -3 is -3, minus 2 times -1 is -2. So this is -3 plus 2, so this is equal to -5. And let's find the determinant of B. Determinant of B is 2, -3, 1, and -1. Cross multiply, so it's 2 times -1 is -2, minus in the formula, and 1 times -3 is -3. So this is equal to -2 plus 3. Oh, somewhere on the way, here we have a mistake. -1 plus 2 is not -5, it's -1. I'm sorry. And we have 1 plus 3 is equal to 1. So we can see that this formula determinant of B is -1 times the determinant of A. So indeed, if you interchange rows, you need to put minus in front of the determinant. Let's check the second property. If you multiply or divide, let's check the second property. If you multiply one row of A by the scalar to obtain another one. So B, we have matrix A. Let's do this general: A, B, C, and D. And matrix B, let's say that we multiply the second. We have A, B, y multiplied by K, KC, KD. Okay? Everyone can see that the second row is multiplied times K. So the determinant needs to be multiplied times K as well. So find determinant of A. Put them A, B, C, and D. and then cross multiply this times this, so it's A times D, cross multiply C times B. That's it, we cannot go any further. Now let's find the determinant of B. Determinant of B, we cross multiply, so we have A times K times D minus K C B. Take K out of the bracket, what's left? AD minus CB. So here we go, this is the determinant of A. So indeed, determinant of B is equal to K times determinant of A. So now let's check the property. Third property, if I add scalar multiple of one row to another row, okay, I am adding scalar multiple of one row to another row, then the determinant must be the same. So this would be C. My matrix A is 1, minus 3, 2, and minus 3. And let's say that I would like to get, so I will multiply row 2 is equal 2 times row 1 plus row 2. So the resulting matrix I will call matrix B. So I have 1 minus 3, 2 minus 2. Minus 2 we would like to have 0. Minus 2, so this one is 0. Minus 2 is 6, and plus row 2. And so we have minus 2 times minus 3 is 6, plus is 3. Okay, so now let's find determinant of A. This one is 1 minus 3, 2 minus 3. Cross multiply, this times this is minus 3. Then minus from the formula, this times this, minus 6. So it's minus 3 plus 6. Minus 3 plus 6 is 3. Okay, now let's find the determinant of B. Those exercises, what I'm showing now is basically to show that those properties are true. Okay, those properties are good to keep in mind if you keep solving examples, and we will have examples shortly. So what we have, determinant, we have 1 minus 3, 0, 3, cross multiply, 1 times 3, minus 0 times minus 3. So this is 3, 0 minus 0, it's 3. So indeed, those two determinants are equal. Determinant of A is equal to determinant of B. So if you add scalar multiple of one row to another row, the resulting determinants are the same. The determinants do not change. So now let's apply those properties. Let's keep solving examples. Find the determinant. Find the determinant. And we have A. Let's do the example that we did before, the first example in the previous lecture. So that was 2 minus 5 minus 3, 5 minus 2, 1, 3, and 1, 3, minus 2. Let's say we would like to make zeros in the first row. Let's say that first put 1 on top, so we interchange row 1 with row 3. If you interchange two rows, you need to put minus in front of the determinant. So we have minus 1 times. And now I have 1, 3, and minus 2. And then we have minus 2, 1, and 3. And then I have 2, minus 3, and 5. Now I would like to make zeros in the first row, in the first column. If I make zeros, then the calculation would be simple. So to make those zeros, how can I make 0? Row 2 is equal to 2 row 1 plus row 2. Okay, so I have minus 1 in front. Copy the first row, 1, 3, minus 2. 2 times 2 times 2, 2 times 1 is 2, minus 2 is 0, 2 is 6, is 7, 2 is minus 4, is minus 1. And let's make 0 on the third spot. So row 3 is equal to minus 2 row 1 plus row 3. Okay, so minus 2 plus 2, 0. And then what we have, minus 2 is minus 6, and minus 3 is minus 9. Then we have minus 2 and minus 2 is 4, plus 5 is 9. So now we can expand, because we still need to find this determinant. So now we can expand by the first column. Expand by first column. We had minus 1 in front, and by the first column would be 1 times cofactor 1, 1, plus, then we have 0 plus 0. Okay, so we are going minus 1 times 1, it's just 1, and cofactor, from cofactor we have minus 1 to the power 1 plus 1 times, delete the first row and first column. So we have 7, minus 1, minus 9, and 9. So this is minus 1, 1 square is minus 1 times 7 times 9 is 63, minus 9. So this is equal to 63 plus 9 is 72, minus 72 is the determinant. If we didn't make mistake, that should be right. Okay, let's see one more example with finding those determinants using the properties. So B. We have 2, 0, 1. Let's say minus 3, 1, and minus 1. And then let's say we have 1, 2, and minus 1. Okay, we can keep expanding by the first row, or let's try to use properties that we can change. In this case, it's not that much beneficial to change because we have already 1, 0, so it's pretty good. But we would like to use the properties. So change the row 1 with row 3. So then we have 1, 2, and minus 1. Second row is minus 3, 1, and minus 1. And then we have 2, 0, and 1. And whenever you change the row, you need to put minus in front. Now we would like to make 0 underneath. So row 2 is equal to 3 row 1 plus row 2. So we had minus 1, and then we have 1, 2, and minus 1. Now 3 times is 0. 3, 6, 7, 3 minus 3, and 1 is minus 4. Okay, and now we would like to make 0 to here, so row 3 is equal to minus 2, row 1 plus row 3. So what we have, minus 2 plus 2 is 0. Minus 2 times 2 is minus 4. And then we have minus 2 times minus 1 is 2 is 3. So now we expand by the first column. So this is minus 1 times 1 times cofactor 1, 1, and plus 0 plus 0. This is 1, 0, 0. So this is equal to minus 1 times from cofactor we get minus 1 to the power 1 plus 1 times, delete the first row and first column. Delete the first row and first column. So what we have, 7 minus 4, 3. The calculation gets simple. This one is square, minus 1 square is 1, so we have only minus 1 times 7 times 3 is 21, minus 4 is positive 16. So this is minus 1 times 21 minus 16 is 5. So the determinant is minus 5. Determinants. One application of determinants is in using Kramer's rule. So now we would like to talk about Kramer's rule. For the system Ax is equal to B, we denote by A sub x the coefficient matrix with the first column replaced by B. So that works like this. Actually, maybe let's write down the Kramer's rule, and then once we solve systems on example, it will be clear. So the Kramer's rule says that x is nothing else but determinant of A sub x over determinant of A. Determinant of A is the coefficient matrix. And then y is determinant of A sub y, determinant of A. And c is determinant of A sub z over determinant of A. Please stay with me, it will be clear on example. So we have used the Kramer's rule to solve the system. I can keep maybe the Kramer's rule. Okay. Use the Kramer's rule to solve the system, and we have simple system. We have simple system A. X minus y is equal to 3. 3x minus 7y is equal to 9. So first we will need, for Kramer's rule, we will need the determinant of A, so coefficient matrix. So A is the coefficient matrix. Is 1, 3, minus 1, and minus 7. So the determinant of this matrix A, cross multiply, 1 times minus 7 is minus 7, minus 3 times minus 1 is minus 3, so the determinant of A is minus 4. That's step 1. We will need the determinant of A. Okay. Now we need to form the matrix A sub x. So it would be the coefficient matrix what we have, except that the x's are replaced by the numbers, by the column B. So instead of the x column, we put the three variables. So it's 3, 9. And then we have y, it would be minus 1 and minus 7. That's the matrix A sub x. It's a coefficient matrix with the first column replaced by B. So look to the coefficient matrix, and this column, basically column that corresponds to x, is replaced by the column of B. So we have 3 and 9. So now determinant of A sub x, cross multiply, is minus 21 minus 9. So we have minus 21 plus 9. Minus 21 plus 9. So this is equal to 12. Okay? And the last step, we need the matrix for y. We need to have Ax, Ay. We don't have z because that would be for 3 variables. So we will use only the first part of Kramer's rule. Okay, so AY. AY is the coefficient matrix with y's replaced by the free variable. So we have for x's, we have 1 and 3, and instead of y's, we put the B column, so it's 3 and 9. So now we have determinant of A sub y, cross multiply, 1 times 3 is 9, minus 3 times 3 is 9, so it's 0. So now we have now we can write the Cramer's rule that x is equal to determinant of this and substitute. I need to move this up a little bit. So now we have that x is equal to determinant of A sub x over determinant of A. Determinant of A sub x is 12 over determinant of A is minus 4. So this is equal to minus 3. Okay, and y is determinant of A sub y over determinant of A. So this is 0 over minus 4, it's 0. So that's the solution. X is equal to minus 3, y is equal to 0. That's the Cramer's rule. I call those matrices A sub x, so you don't confuse. That means x is replaced. X is replaced by this column. A sub 1, y, that means for y, then the y column is replaced by the 3y, 3, 9 column. One more example using Cramer's rule. So we have example B. Okay, we have x plus y plus 2z is equal to 4, minus x minus y minus 3z is equal to minus 5, 2x plus y plus z is equal to 2. So first start with the coefficient matrix A. So A, coefficient by x is 1, minus 1, 2. Coefficient by y is 1, minus 1, 1. Coefficient by z is 2, minus 3, and 1. Okay, now we need to find the determinant. So let's first change a little bit, make zeros in the first row, make 0 and 0 in those positions. So will R2 is equal to R1 plus R2. The determinant will not change, so this would be my determinant of A. I will write like this. I have 1, 1, 2, and 1 is 0, 1 is 0, and then what we have? 2 plus minus 1 is minus 1. And now our row 3 is equal to minus 2 row 1 plus row 3. So minus 2 is 0, minus 2 plus 1 is minus 1, and minus 4 plus 1 is minus 3. So now we can expand. Now we can expand by the first column or by the second row. I will expand by first column. So this is 1 times the cofactor of position 1, 1 plus 0 plus 0. So this is equal to 1, it doesn't change anything, so I have minus 1 to the power 1 plus 1 times, delete the first row, first column. So we have 0, minus 1, minus 1, minus 3. Minus 1 to the power 2 is 1, so I have 0, minus 1 plus 1, so this is minus 1. The determinant of A is minus 1. Now we need to find A sub y, A sub x. So the column of x's is replaced by the free variables. So we have 4 minus 5, 2, and then we copy y's is 1, minus 1 and 1, and z we have 2, minus 3, and 1. Not that much we can do. Maybe let's make at least 1 0. So let's multiply. So let's multiply to get 0 in this position. So we can multiply row 1 is equal to minus 2 times row 3 plus row 1. So this is equal to minus 4 plus 4 is 0, minus 2 is minus 1, minus 2 and 2 is 0. And then I have minus 5, minus 1 and minus 3, and then we have 2, 1 and 1. So this is, now we can expand by the first row. So this would be determinant of a sub x. We expand by first row. So we have minus, at first would be 0 plus minus 1 times the cofactor first row, second column, and plus 0. So this is minus 1. From cofactor we have minus 1 to the power 1 plus 2 times, delete the first row, second column, so we get delete the first row, second column, so we have minus 5, 2, minus 3, 1. So this is equal to minus 1 to the power 3 is negative 1 times negative 1, it's positive 1. So we don't need to write anything. Minus 5 times 1 is minus 5, minus 6. So this is equal to 1. And now we need to do for a sub y and z, a sub z. So a sub z, a sub y. The y column is replaced with the free variables. So we have 1, minus 1 and 2 for x. Now instead of y we are substituting this column for minus 5 and 2. And then z we have 2, minus 3 and 1. So let's make some zeros. So row 2 is equal to row 1 plus row 2. So what we have, first row doesn't change, 4 and 2. Here would be 0. 4 minus 5 is minus 1. And 2 minus 3 is minus 1. And row 3, we can multiply minus 2 row 1 plus row 3. Minus 2 plus 2 is 0. Minus 8 plus 2 is minus 6. Minus 4 plus 1 is minus 3. So now determinant a sub y is equal to, I expand by the first column, so it's 1 times cofactor of 1, 1 plus 0 plus 0. So this is 1 times, from cofactor we have minus 1 to the power 1 plus 1 times, delete the first row, first column, minus 1, minus 6, minus 1, minus 3. Cross multiply, so this is equal to minus 1. This would be positive number, of course, minus 1 square is positive number. Then we have 1 times minus 1 is positive 1 times minus 3. Minus 1 times minus 3 is 3. Minus and 6. So this is minus 3. And now we need to do for z, the same way for z. So what we have for this az, z column will be replaced by the free variable. So we have 1, minus 1 and 2, then 1, minus 1 and 1, and then we have 4, minus 5 and 2. So let's make zeros below. Row 2 is equal to row 1 plus row 2. So we have 1 and 1 and 4. Then we have 0, 0, minus 1. And then we have row 3 is equal to minus 2 row 1 plus row 3. So minus 2 plus 2 is 0, minus 2 plus 1 is minus 1, minus 8 plus 2 is minus 6. Now expand by the first column. So determinant of A sub z is equal to 1 times the cofactor of 1, 1 plus 0 plus 0. So it's 1 times minus 1 to the power 1 plus 1 times, delete the first row, first column, so we have 0, minus 1, and 6. So this is 0, minus 1, it's minus 1. And now write the Kramer's rule that x is equal to determinant of A sub x over determinant of A. So what was the determinant of A sub x was 1. Determinant of A was minus 1. So this is minus 1. Now we had that y is equal to determinant of A sub y over determinant of A. So determinant of A sub y is minus 3 over minus 1, so this is 3. And the z is equal to determinant of A sub z over determinant of A. So this is minus 1 over minus 1, so this is positive 1. So we had that x is equal to minus 1, y is equal to 3, and z is equal to 1. Last thing from this section I would like to show you is applications. One of the applications is to find the area of a triangle. If points P, Q, and R that has coordinates x sub 1, y sub 1, x sub 2, y 2, x3, y 3 are the vertices of a triangle, then the area of the triangle is given by this formula. So basically you put x first coordinate, first point to the first row, second point, and third point, and add the 1 columns. So it's 1/2 times the determinant of this, and pick either plus or minus to make positive area, because area is always a positive number. So let's see on example how that works. Find the area of a triangle with vertices 0, 0, 12, 0, and 12, 5. So we said that area is equal plus or minus 1/2 times the determinants 0, 0, 1, 12, 0, 1, and 12, 5, and 1. So we need to find this determinant, expand by the first row. So we had plus or minus 1/2 times 0 plus 0 plus 1 times cofactor position is first row, third column. So we have plus or minus 1/2 times 1 times, from cofactor we have 1 to the power 1 plus 3 times, delete the first row, third column. So we have determinants of 12, 0, 12, 5. So this is plus or minus 1/2. Minus 1 to the power 4 is positive 1. So we just need to only find cross multiply. 12 times 5 is 60 minus 0. So this would be 1/2 times 60. The area is 30. So the area of the triangle is 30